let an equal to 1 upon 3 raised to the power n when n is prime, and an equal to 1 upon 4 raised to the power n if n is not a prime. Then the radius of convergence of the power series summation an x raised to the power n when n running from 1 to infinity. Here we have to find radius of convergence of this power series, and this power series obtained by the sequence an, and an terms of an can be written as 1 upon 3 raised to the power n when n is prime, and 1 upon 4 raised to the power n when n is not prime. So terms of sequence an can be obtained by this two formation 1 upon 3 raised to the power n type and 1 upon 4 raised to the power n type, and we have to find the radius of convergence of the power series an x raised to the power n. So as an is given in two structure when n is prime and n is not prime, means set of natural number is divided into two categories, n is prime and is not a prime. So we can split this power series in two, and we have to find the radius of convergence for power series when n is prime and n is not a prime. So we are considering two cases. Case 1 when n is prime and its radius of convergence is R1, capital R1. Then capital R1 can be obtained by limit un upon un plus 1, or here an is used, so an upon an plus 1, or 1 upon limit un raised to the power 1 upon n, an raised to the power 1 upon n, or these are only way of writing radius of convergence r equal to limit an upon an plus 1, or r equal to limit an plus 1, so it will be 1 upon r, an equal to limit un raised to the power 1 upon n. So these are only the way of writing, and our an is in the form raised to the power n, it means exponent type. So this format is most appropriate as root test. So I'm going to find radius of convergence by root formula. So it will be radius of convergence R1 when n is prime equal to limit n tends to infinity 1 upon an and raised to the power 1 upon n. It will be limit n tends to infinity, and an is what? An is 1 upon 3 raised to the power n, 1 upon 1 3 raised to the power n, and raised to the power 1 upon n. This will be limit n tends to infinity 1 upon 1 by 3, or it will be 3. So radius of convergence for power series when n is prime is 3. Now we are going to case 2 when n is not a prime. So radius of convergence R2 equal to limit n tends to infinity 1 upon an raised to the power 1 upon n, same formula. Limit n tends to infinity, and here an is, when n is not prime, 1 upon 4 raised to the power n. Use this 1 upon 4 raised to the power n and raised to the power 1 upon n. It will be limit n tends to infinity 1 upon 1 4 raised to the power n and raised to the power 1 upon n. It will be 4. It will be 4. So radius of convergence R2 equal to 4. Suppose this is radius of convergence R3. It means, sorry, 3, and this is the radius of convergence R2. So we take minimum, because if we choose max, then this point power series may be divergent. So we choose minimum of this radius of convergence. So radius of convergence of the power series summation an x raised to the power n and running from 1 to infinity will be radius of convergence. So I write capital R, min of 3 and 4, and it is 3. So radius of convergence is 3. Now check which option is true. Option B is true here.